Today I'll be showing you how to install Kratix on GKE, how to register a work cluster with Kratix, and showing you the basics of how to use a promise. I'll be following the docs on the Kratix.io website, and I'll leave a link to them in the description. We've also created a Kratix examples repository that will contain the manifests that I'll be using throughout this installation process, including documentation on how to create any of the secrets that are needed as well. So, following along with the docs, the first thing we need to do is set up our platform cluster. In this case, I've already pre-created a GCP cluster, but if you don't have one, you can go ahead and follow the GKE Getting Started documentation. In this case, I've already created my platform cluster. So the first step is to log in. Cool. So now we have fetched the queueconfig for the platform cluster. We're going to set a handy invariant variable throughout this demo to make it easier to reference back between the worker and the platform cluster. So let's go ahead and get the name of our current queueconfig and export an invariant variable equal to that. Cool. So we're now logged in and we have access to the platform cluster. So the first step of installing Kratix is installing one of its dependencies, which is Cert Manager. So let's go ahead and install Cert Manager onto the platform cluster. So Cert Manager is a Kubernetes project for provisioning certificates. Kratix requires it as a dependency because it requires some certificates to operate. More specifically, it has some webhooks that require certificates to communicate with Kubernetes. Now that we've installed Cert Manager, let's wait for the pods to be running. So what we can do is inspect the pods that are running in the Cert Manager namespace and wait for them to be running. Cool. We can now see that Cert Manager is up and running on the platform cluster. The next step is to install Kratix. So in this case, we're taking the latest release of Kratix, but if you want to use an older release, you could go to the repository and browse for a different version. Cool. Now that we've installed Kratix, let's look at the pods in the Kratix platform system namespace and wait for them to be running. So we can see we're at 1 out of 2 being ready, and we're now at 2 out of 2. So Kratix is now fully installed on the platform cluster and ready to go. So the first thing after installing Kratix you want to do is set up a state store. So a state store is a place where Kratix will write documents to, and an external tool can pull those documents down and install them. So the typical example being a GitHub repository or an S3 compatible bucket that you write files to, and then something like Terraform or Flux or Ansible can read those files and then react to them. So in Kubernetes, it might be a GitOps agent pulling those manifests and deploying them to the cluster. So in this case, we can create either a Git state store, so tell Kratix to write to a Git repository, or we can create a bucket state store, so any S3 compatible buckets. Because I'm running on GCP, I'm going to be using a GCP bucket as my state store. So what I have already done is created a manifest for this. So if I show you my bucket state store, you can see I am telling Kratix to write to the Kratix worker bucket that I have already created in GCP. And I'm pointing at a set of credentials that I have also got locally ready. I'm not going to show them. But if you want some documentation on how to go ahead and create those credentials, they'll be in the quick start documentation. So what I'm going to do is I'm going to install the bucket state store and the secret for it as well. So on my platform cluster, I'm going to install my bucket state store secret first, and then my bucket state store. So my secret just contains the access credentials for communicating to the bucket. So if I run kubectl context platform get bucket state stores, I can now see the default bucket state store has been installed. So we've taught Kratix about how it can write files to this bucket that exists in GCP. The next step is to register a destination with it. So in this case, I'm going to set up a worker cluster. So the first thing I need to do is tell Kratix about this destination. So in this case, we're going to create a worker cluster, and it's going to be using a bucket state store. So I'm going to take this manifest and modify it. So I've already done that. So if I show you my destination, you can see that I have already created a worker destination. And in this case, I pointed it at my bucket state store that I was using before. If you were using a Git state store, you would replace the word bucket state store with Git state store. If it had a different name, you would swap the name out. And this is just a pointer to what place it should write to when writing to this destination. So I'm going to go ahead and install this. And now we're done. So we've taught Kratix about a place it can write files to. We've taught Kratix about when it's scheduling files to this worker cluster, this worker destination, sorry, it should write to that state store. So the next step is to set up the state store, to set up the worker, sorry, to actually pull down the files from that state store. So the first thing we need to do is create the worker cluster. So in this case, I've already created one. But if you haven't got one, you can follow the getting started steps for GKE on how to create a cluster. So in this case, I already have my work cluster provisioned here. So much like before, I'm going to log in to that cluster on the CLI and export an environment variable. So let's go ahead and log into the work cluster. Let's get our current context. So we can see this is called the GKE US Central 1 work cluster. And let's export the worker environment variable to be equal to this. Cool. So there's two steps involved with setting up the work cluster. The first one is installing Flux. So what you can do is go to the Flux documentation, or Argo if you want to use Argo, and follow their installation guides. In this case, I'm just setting up a cluster as a demo to test around and play around with. So I'm just going to use a handy manifest that pre-exists in the Kratix repository. It's just a point in time set of manifest for Flux. But if you want to use this cluster for more than just testing, I'd recommend going to the Flux docs and installing from their recommended documentation. So I'm going to install this. Now that it's installed, we can watch the pods in the Flux namespace and wait for them all to be running. Cool, so we can see all of the pods for Flux are now running, so Flux is installed and healthy. So the next step is to configure Flux. So like I was saying, we need to configure Flux to pull down from our Kratix worker bucket that we've created. So in this case, we need to create a bucket resource. There's documentation on the Flux docs on how to do it. I've already got one created locally. And then we need to create two customizations. This is the bit that actually tells Flux to apply the manifests that are in that bucket. So you can copy and fill this in. I've already got a working copy locally. So if I show you, I've already got my bucket.yaml. So in this case, I'm telling Flux to communicate to the Google S3 API, S3 compatible API. And I'm also telling it to use a set of credentials that I have created locally. And then if I show you the customizations, we're creating two separate customizations, one for installing the dependencies and one for installing the resources related to the resource requests. We have a split to make sure that any dependencies are installed before any resources are installed to prevent any ordering issues. So I'm going to go ahead and install these. So on my worker cluster, I can apply my bucket. So I'm going to apply my bucket secret first. Then I'm going to install my bucket. And if I get my buckets, we should see that eventually it becomes healthy. So we can see it's successfully gone to the GCP bucket and pulled down the files. So that's good. So now that's healthy, I can install the customization. So let's apply the customization. Now, if we get these customizations, we can watch to see until they're healthy as well. So we can see the dependencies one is healthy, and then eventually the resource one will be healthy as well. Cool. So we can see that's healthy now. So what Kratix does is it will deploy two canary resources as part of setting up a destination. So we should see that there is a namespace called Kratix worker system, and we should also see within that namespace there is a config map. Now that we can see that both those canary resources are created, we know that we have successfully wired up the worker cluster to pull down from the state store that Kratix is writing to. So that's it for the installation. We now have a working Kubernetes installation of Kratix. on GKE. So the next thing I want to do is show you how to use a very simple promise. So we have a Kratix marketplace. Uh, this is a marketplace of promises that you can go and play with and install. For the sake of this demo, I'm going to show you how to use the Google Cloud SQL promise. In this case, a promise that provides SQL instances in GCP on demand. So in here, you'll find some documentation on how to create any of the credentials required for this promise, as well as the promise itself and some example requests. Okay, so let's create this secret. So I've already got locally a copy of the service account that I'm going to use to give the promise access to my GCP account. And I'm going to use my Kratix project. So I'm going to go ahead and run this command. So this will create the secret on the platform cluster, passing in the service account.json and pointing at my Kratix project. So we've now got the secret created. So now we can go ahead and install the promise. So I've already got a copy of this promise locally. So what I can go ahead and do is install this. So if I, on my platform cluster, install my promise, we can then see that the promise is installed and available. So I can now request SQL on demand. And if I go ahead and make a request for this promise, we can see that the request has been accepted. We should see that the workflow for this promise is going to fire. So here you can see the container is running to deploy, to create the SQL instance. So we can see here that our example instance is being created. In summary, we've showed you how to install Kratix on Platform Cluster on GKE. We've showed you how to register and configure a work cluster with Kratix. And we've also demonstrated how to use the GCP SQL promise. If you're interested in learning more about Kratix, I'd recommend going through the rest of the guides we have on our Kratix.io website, as well as playing around with some of the other promises we have available in our marketplace. I'll leave a link to all these websites in the description of this video, but also they're available on screen here. You can either go to the URL specified or scan the QR codes. Thank you for watching.